Hello, this video tutorial is all about the wind side of the CRP5. This device allows us to illustrate and to calculate the effect of wind velocity on aircraft velocity. The reason I'm saying velocity as opposed to speed is, of course, velocity is a
vector. That's me.
Yes, it is.
I'm committing crimes with both direction and magnitude.
What he said.
Yeah.
Direction and magnitude. Magnitude, in the case of the aircraft velocity, is the aircraft speed through the air. For a given block of air, taking up a certain number of miles, we call these nautical air miles, the aircraft will fly through it at a particular speed and take a certain amount of time to cover these miles. We call that its true airspeed. Now, if the air does not move, the true airspeed will be the same as the speed over the ground, i.e. the ground speed. But of course the air does move. That's what we call the wind. If the wind is in the same direction as our desired direction of travel, we call that a tailwind, and our ground speed will be greater than our true airspeed. And the opposite applies. If the wind is moving in the opposite direction to our desired direction of travel, we call that a headwind, and our ground speed will be lower than our true airspeed. In terms of direction, well, the aircraft has a direction, the direction we're pointing it. We call that the aircraft heading. And again, left to its own devices, ignoring asymmetric thrust for just a moment, the aircraft will move in the direction that it's pointing. However, the air moves. If the air moves, then the direction the aircraft travels over the ground will be different from the direction it's travelling through the air. If the heading is the direction it's travelling through the air, the direction it's travelling along the ground, we call its track. And the difference between those two is called drift. We always drift from heading to track. In this case, we have a wind from the left which is causing a right drift, approximately 20 degrees of right drift from my heading onto my track. If the wind were coming from the other direction, we would be having 20 degrees of left drift. We drift from heading to track. So, how the aircraft travels over the ground is a ground vector, its track and its ground speed. And that's a resultant of two other vectors, the air vector, how the aircraft travels through the air, and the wind vector, how the wind itself travels. And if we know any two of these vectors, we can calculate the third one. In fact, we can go further than that. Since each of these vectors consists of both magnitude and direction, we have 6 quantities. The air vector, which is heading and true airspeed, the wind velocity, which is wind direction and wind speed, and finally the ground vector, which is track and ground speed. If we know 4 out of these 6 quantities, we can calculate the other 2. And that's essentially what the CRP5 wind side allows us to do. The CRP5 wind side presents this information in what I like to call the default setting, or the default position, where the aircraft's heading is there, where it says true heading, and its true airspeed is under the centred dot. So there is the air vector. Somewhere on the surface is a little mark, and that mark is the effect of the wind, essentially is the wind vector. And it affects the air vector to produce the resultant ground vector, which is expressed as ground speed and as track, but not directly as track, rather it is presented as drift. But since we know that we always drift from heading to track, knowing the drift, we can deduce track from heading, or indeed heading from track. So take a note of this default position. Heading under the heading indicator, true airspeed under the centre dot, and a mark in illustrating the effect of the wind, giving us track and ground speed. So with all that in mind, the process for using the CRP5's wind side is basically the same every time. What do we know? What of these 6 things do we already know? And how many of those can I immediately record on the CRP5? Typically, you will know at the beginning what the wind is, the wind velocity, both its speed and direction. So that's the first thing to do. Mark the wind down on your CRP5. We'll show you what marking the wind down looks like in just a moment, but in essence, the theory says that if I know where the wind is and I turned the aircraft into that direction, I would get zero drift. If I knew the speed of the wind, I would know that the ground speed will be exactly that amount less than the true airspeed. As a result, I'm in a position to be able to record that information so that now when I put in my actual heading and my actual true airspeed, the resultant vector of track and ground speed will become apparent to me. Having marked the wind down, we then set heading if we have heading and true airspeed if we have true airspeed. Where the wind mark that we have already made ends up will give us track and ground speed, in other words the ground vector. We'll have a look now at a couple of examples where we know the wind, we know the heading and we know the true airspeed, and we have to calculate track and ground speed. Here's the first one. So let's have a go at answering this. So with this question, we already know the wind, so apart from making sure that I'm on the low speed side of the CRP5, the first thing I'm going to do is mark the wind down, really without thinking about anything else. So the wind direction, I'm told, is 090 degrees. So I'm going to set that there under the heading. And my ground speed then will be 20 knots slower than my true airspeed. Doesn't really matter where I put the centre dot, but for ease I'm going to put it right there on the 0 line and mark a point that's 20 knots below that as accurately as I can. That cross now is the effect of the wind in this scenario. 090 degrees, 20 knots, wind marked down. Now I just put in the rest of the data that I have available to me. So I am told that the heading is 327. That's there. With the wind from the east, I would expect a tailwind and left drift, which is what the wind cross is showing me. And I'm told that the true airspeed is 130 knots. So let's just put TAS straight under the dot. So there we go. 130 knots there. So here we have the default position, if you like. True heading under the true heading indicator. True airspeed under the centre dot. And then a cross over here giving me drift, which is 7 degrees to the left, and a ground speed of 142 knots. With a drift of 7 left on a heading of 327, my track would be 320 degrees. So the answer here is that the track is 320 degrees and the ground speed 142 knots. And here's the second one. And again, here's the answer. So again, in this occasion, I've been given the wind direction. So apart from making sure that I'm on the high speed this time, because the TAS of 450 knots looks like it's going to be on the high speed side. Other than that, I'm just going to go through the same process. Let's mark the wind down first of all. So wind direction 110 degrees. Set that there. Wind speed 65 knots it says. So I'm just going to set, well, I can set the true airspeed dot, for example, on a true airspeed of 465. There we go. So that's the 450 line there. That's 460. That's 465. 65 knots below that is going to be at the 400 mark. So there we are. I've marked the wind down. That's all I needed to do there. There's the wind direction up there and a gap between the true airspeed and the wind dot, as it were, of 65 knots. So that's the wind marked down. Now all I need to do is put in the other data. 145 is my aircraft heading, true heading of the aircraft. And I'm told that the TAS is 450 knots. Well, that's handy, I don't have to move that terribly far on this occasion. 450, again, as accurate as I can get it. So 450 knots there, centre dot, 145 on the heading. I've got around about, shall we say, let's go just ever so slightly, that's about right, 5 degrees now of right drift, and it looks like the ground speed just under 400 knots, maybe 398. So on this occasion, heading is 145, drift 5 degrees right, therefore the track 150, true airspeed 450 knots, ground speed just less than 400, let's say 398. Okay, sometimes we know the wind velocity and we know the track and we know the true airspeed. This in fact is quite a common occurrence if you stop to think about it. We would normally have the meteorological service giving us a forecast or actual wind. We would know, or at least be able to calculate, what the true airspeed of the aircraft will be, and we'll know the track because we've planned the flight on our map or chart and we have measured the track. So all we've got left to do is calculate the heading that we need to fly and compute the ground speed, enabling us to work out how long it's going to take to fly that particular leg. The thing is that the default position that we mentioned earlier of the CRP5 has the true heading under where it says true heading. If I don't know the heading, how can I do this? What we're going to use is a technique called balancing the drift. Essentially, we turn the aircraft so that its heading is the same as its track. Now we know that the aircraft will not maintain that track because the wind is not a complete head or tailwind. It is going to be blown off course. But how much, in other words, what the drift angle is, will allow us to adjust the heading appropriately. However, now that we've adjusted the heading, the drift itself may also change, which means we're going to have to adjust the heading again. We continue to repeat that process until eventually we have a situation where we've got heading and drift, which gives us the track that we actually want. So let's have a look at this one in action. Let's look at a question where we've got wind velocity and we've got true airspeed and we've got track, but what we're trying to calculate is heading and ground speed. Here's one. The difficulty with this sort of problem is that the true heading of the aircraft is not given to us. We have to calculate the true heading. So we know in advance we're going to end up having to do some drift balancing with this one. But before we panic too much about that, apart from making sure that we're on the correct side, low speed side it looks like, let's set about marking the wind down just straight off the bat. So 239 degrees is my heading. There we go. 239 set there under the heading. And I'm going to mark 30 knots of wind. So let's put the airspeed dot on the 0 mark and let's mark 30 knots under there. There we go. 230 at 30. And be as accurate as you can with that little cross there. So 239 degrees at 30 knots, that's the wind. We know that the true airspeed is 132, so let's set 132 knots under the centre dot, and that's going to be 130 second arc there, about there. And we can confirm, by the way, that the wind dot is still 30 knots below the true airspeed dot, showing 102 knots on ground speed. In other words, if I turned the aircraft into wind, my ground speed would be 30 knots lower than my true airspeed, which sort of makes sense. Now, here, as I say, we're not given the heading yet, but we are given the track. So what we'll do first is we'll make the track the same as our heading. So we'll make our heading 010 degrees. We know we're going to get some drift there, or it is very likely we're going to get some drift, unless it's an absolute head or absolute tailwind. And indeed we are getting something like 8.5 degrees of drift out to the right. let's assume for the moment that that is the correct amount of drift. What heading would I need so that applying that drift will give me the correct track? The track that I want is 0, 1, 0 degrees. So with 8.5 degrees of right drift, the heading that I want would be 0, 0, 1 and a half, which is extremely accurate, but you know, why not? But now the drift has changed. Now the drift is showing 9.5 to the right. So I've got an extra 1 degree, 1.5 in there. Let's therefore think to ourselves, what heading would we need, which when that drift is applied would give us the right track? Well, another 1 degree to the left, or 1.5. Let's take it to 360 degrees. There we go. So now I'm in my default position. True heading, 360 degrees, giving me 10 degrees of right drift, which gives me the track that I want of 0, 1, 0. And the true airspeed is still 132 knots. My ground speed is 150 knots. So there we go, that's drift balancing. Firstly, align your heading with your track, see how much drift that gives you, and then adjust your heading and keep repeating that process until such time as the heading plus the drift gives you the track that you want. Okay, that's drift balancing. Let's have a go at a second one. So one more time with drift balancing, I've selected the high speed side. So now, first things first, don't think about anything else, mark the wind down. 210 degrees is the wind direction and 70 knots the wind speed. Well, we can do that down here if we really want to. There we go. So 50, 60, 70, that's that just there, again being as accurate as I can. So there's the wind marked down, 210 degrees at 70 knots. And I am told that the true airspeed is 550. Or perhaps I have calculated that it's 550. Either way, that's what I'm now going to set. Okay. And the heading, I don't know yet. But I do know the track. Let's set track 065 as my heading, knowing that I'll probably get some drift. Yeah, I have 4 degrees of left drift just at the moment. Well, okay, if the track that I want is 065 and the drift is 4 left, that means that the heading that I'm going to want to set is 069. So now, am I in the default position? Have I got a heading and a drift that will give me the track that I want? Well, 069, 4 degrees of left drift, gives me the track of 065, which is what I want. Meanwhile, my true airspeed is 550 knots, and my ground speed is a little less than 610, 607, 606, something like that. So there's my heading, there's my drift, there's my ground speed, there's my true airspeed. And again, I have effectively balanced the drift. Now, sometimes you're not given the wind velocity. You're asked to calculate the wind velocity. So let's look at this example here. Again, what have we got? We've got heading, we've got track. That means we've got drift. We've also got true airspeed and we've got ground speed. So all we need to do is put those data onto our CRP5 somehow and see what it gives us in terms of the wind. So let's have a look at this one. So with this sort of question, we're not given the wind, so we can't do the first thing first of mark the wind down. But what we are able to do is just put in all the other data that we have available to us. So heading 344, okay, I've no idea where this is going. I've got an inkling that we're on the low speed side, but apart from that, 344 is the true heading, so that's there going under the true heading mark. And then the true airspeed, I'm told, is 91 knots. Slow aeroplane, but there we go. So 91, that's about there, somewhere between 90 and 92. Should be 91. There we go. So there's the true airspeed, there's the heading, and I am told that my track is 348, which is 4 degrees of right drift. So that's 2, 4, somewhere down this line here, the 4-degree line. And I'm told that my ground speed is 99 knots, which is there. So the point where those two things intersect is going to be my wind dot. Well, all well and jolly good, but what do I do with that information? Well, what do I normally do if I do know the wind? I start by marking the wind down. So here I can finish by marking the wind down effectively. I'll move the true airspeed dot back to 0. I don't necessarily have to, but just to sort of illustrate the point really, and swing this around until such time as the wind dot is directly under the center dot, which seems to be about there. Well, now I can just read it off. What direction have I got there? 206 degrees and 10 knots. So the wind is 206 at 10. Okay, and let's look at this one. So similar idea with this one, making sure I'm on the correct side. I am. Can't mark the wind. What data do I have available? I've got 044. Okay. 044 is my true heading. What else do I know? I know that the true airspeed is 146. Well, I can put that in. 246. There we go, centre dot under 146. Fine aircraft. And I am told that my track is 034. So I've got to do a little bit of deduction there, but if the heading is 044 and the track is 034, then that's 10 degrees of left drift. So that's somewhere on this line radiating out here. And I'm told that the ground speed is 126. So that's going to be down here, 122.46 at the intersection of those two bits there. So for ease we can erase those. So in other words, at this true airspeed of 146 knots and on this heading of 044, the wind is giving me 10 degrees of left drift, thus creating a track of 034 and a ground speed of 126. So there's the ground vector and the air vector. What's the wind vector? Well, again, what would I do at the beginning of the question if I knew the wind? I would mark the wind down. So let's reverse engineer. Let's rotate it so it's directly under the center dot. And I'm also going to put my center dot somewhere where the maths gets a bit easier. So let's put the center dot on 150 just to aid my mathematics. And rotate it so the center dot, the wind dot, sorry, is directly under the center dot. And at that point, the heading is 090. And the difference between true airspeed and ground speed now, 1020, is 30, maybe just a shade over. So 32. So the wind we can calculate is 090 degrees at 32 knots. And just by way of illustrating the point I made earlier, that is, if I know any four, I can calculate the other two. So let's say what I'm looking to calculate is the wind speed and the aircraft track for some reason. I know the wind direction, I know the aircraft heading, I know the true airspeed, I know the ground speed. Is it possible I could calculate, therefore, wind speed and track? Yes, it is. Let's have a look. So in this case, we know the wind direction and the heading and the TAS and the ground speed. What we don't know, just at the moment, are the track and the wind speed. Okay, bit weird, but why not? So the heading is 175. Let's just throw this let's throw the data we know in there already, right? Heading 175, TAS 187, okay. It's about there. Ground speed 186, and the wind direction is 260. Well, we've got a few options here, but why don't we, just for the sake of form, put 186 as my ground speed. Could be anywhere on this arc. So now I know that the ground speed is in there somewhere, and I know that the wind direction is 260. So let's metaphorically turn our aircraft into wind. 260. And see where our ground speed arc crosses the centre line. About there, I'd say. And it's curving away from it, and then it's curving away from it, so it touches just there. So now we've got our wind dot. We've got our wind dot 10 knots below the true airspeed dot. So the wind direction, the wind speed, sorry, now is 10 knots. The wind is 260 at 10 knots. And what's the track? Well, now we've got the wind mark. I know that the heading is 175. So with the heading of 175, the drift out to the left is 3 degrees. So heading is 175, 3 degrees of left drift makes 172 as being my track. So far we've looked at how the wind velocity affects the aircraft velocity by converting heading to track and true airspeed to ground speed. Sometimes though we're interested in knowing in advance how the wind is going to affect our performance on a runway. Aircraft typically want to take off with a headwind, and how much of a headwind will affect aircraft performance. And similarly, aircraft will be limited to a maximum crosswind component as well. In other words, for a given runway, we need to be able to resolve the overall wind velocity vector into its crosswind component and the head or tailwind component as it applies. That's where the lower section of our CRP5 wind side comes into play. The process for calculating headwind, crosswind, tailwind is pretty much the same as when we use the upper section. That is, we start by marking the wind down where possible. But what this gives us is, rather than a relative measure of drift, it gives us the absolute measure of crosswind and head and tailwind components. Let's start with an example where we're going to take off from runway 03 with the wind 070 degrees at 20 knots. How much of that is a headwind? How much of that is a crosswind? So for calculating head and crosswind components, what we're going to use is the square section down here, which gives us, instead of drift in terms of degrees, it gives us an absolute measure of the number of knots crosswind and indeed head and tailwind that we have. But the same principle applies as with the other wind calculations. Where we can, first things first, mark the wind down. So centre dot right there on the 0 line. Wind direction is 070. That's that. And the wind speed is 20 knots, which is pretty much there. Wait for it. Okay, so 070, 20 knots. That's what the wind is doing. But we're not taking off in that direction. We're going to point the aircraft in this direction. Just a quick word of caution. It says true heading here. Of course, runway direction is in degrees magnetic. Runway 03 would be 030 degrees magnetic. But the wind passed to you by air traffic control, by the control tower, is also in degrees magnetic. So providing that we're working in the same degrees for both the wind and the runway direction, this calculation will work. So our direction, our heading is 030 degrees. Now the wind is obviously blowing us out to the left, and we can see that it's a crosswind of 10, 12, 13 knots out to the left, and a headwind of 15 knots. Okay, there's one. Let's have a look at another one. So with this one, again, without thinking too much about it, mark the wind down. And you can do this in real life if you want to find out if where you're heading is out of crosswind limits or not. So the wind is 320 degrees at 15 knots. There's the 320. There is a speed of 15. There we go. I've marked the wind down. Always where you can, mark the wind down first. But we're not taking off in that direction. We're taking off from runway 12, which already should be quite apparent is more than 90 degrees removed from that wind. So that's going to be a tailwind of sorts. And indeed, that is shown by the fact that the wind dot is now forward of my centre dot. The trouble is how to measure that distance. The CRP 5 is not set up for the use of pilots who want to take off with a tailwind. Frankly, nor should it be. So what we're going to have to do is slide this down so that the wind mark is on the 0, and now the true airspeed centre dot is showing me the difference between those two as the amount of tailwind that I've got. So in this case, crosswind is about 5 knots out to the right, and it looks like I've got a 14, yes, I would say so, 14 knot tailwind with the wind mark forward of, in front of where my centre dot is. Sometimes we may be asked to calculate maxima and minima when it comes to head and crosswinds. Aircraft have a maximum crosswind limit. Let's look at one example of that now. So for these sorts of questions, where we're looking at maximums and minimums, it's important to know where the line is and what side of the line you want to be. So in this case, we're told we're taking off from runway 27 and we want a maximum 20 knot crosswind. We're also given the wind direction, so we want to know what's the maximum speed given the wind is coming from that direction. So runway 27 means my aircraft heading would be 270. Putting the centre dot on 0, the maximum crosswind I can accept is 20 knots in either direction. So either 20 knots out to the left or 20 knots out to the right. So when I now come to mark the wind down, if I indeed knew the wind, it needs to end up somewhere between those two lines. We're actually told that the wind direction is 320. If the wind's coming from 320, 320 at 0 knots is obviously fine, 320 at 10 is fine, 20 even is fine. It looks to be that the maximum possible wind from 320, given a crosswind limit of 20 knots, is 26. So the maximum wind speed from 320 is 26 knots. At that wind speed and direction, the crosswind for runway 27 would be 20 knots, bang at maximum. Sometimes for takeoff, for example, an aircraft may have a minimum headwind requirement. So once again, this is a maximum minimum type conversation. So we are going to set our aircraft heading to 180 because that's the runway heading, and if the wind were coming straight down the runway on that track, we would need it to be in excess of 10 knots. So anywhere behind that line, anywhere, in other words, in this section down here. 180 at 20 would be fine, 180 at 30 would be fine. But we've actually got the wind coming from 220. So the wind is going to need to be stronger than a mere 10 knots in order to give us the headwind component we require. And as you can see, there's now a gap between the 10 knot line and the blue line that I've drawn. I'd say that that's about 13 knots. So if the wind is coming from 220, I need it to be at least 13 knots to give me the 10 knot headwind that I require. Similarly, sometimes an aircraft may have a maximum tailwind component. Here we're given an example of a maximum tailwind. And we've got a problem, which is that it's very hard to illustrate a tailwind on the CRP5. What we're going to have to do is we're going to have to slide the centre dot down onto the 10 line so that I can mark a 10 knot tailwind. And what we've said is that for runway 16, so my aircraft heading is 160, the maximum tailwind I can accept is 10 knots. So if the wind were coming from down here, 340, at anything more than 10, that would be too much. So again, the wind must end up being this side of the line. Well, the wind is actually, I am told, coming from 280. So if I were to mark that wind down, I would be setting a wind direction of 280, the centre dot over on the 0 line now, and look at where that maximum line is cutting the centre, 20 knots. In other words, if the wind is 280 degrees at 20 knots, then on a runway track of 160, that's a tailwind, more specifically, a 10 knot tailwind, as we can see. So there we are. Those are the basic techniques of use for the CRP5. By way of practice, I'm going to leave this set of problems on the screen. You'll see that the things to be calculated have been left blank. That'll be left there for 10 seconds, and then enabling you to pause the video, and then the answers will be revealed one by one to again allow you to pause and work through at your own pace. Hopefully, once you've done that, you'll have mastered the wind side of the CRP5. I wish you all the very best.